So in this last section, we're going to look at some inequalities with quadratic functions, and we're going to look to see where the inequality is true. So we want to know when the values of x squared minus 4x minus 12 are greater than 0. So when these values are positive in this case. All right, so we're going to pretend that this is an equal 0, and this is just a quadratic equation that we need to solve. And if we remember the ways that we can do that, we can factor, complete the square, use the quadratic formula. But if I think about factoring in this case, I want to find the numbers that multiply to be 12 and add to be negative 4. So I could have numbers that multiply to be 12, 6, and 2. And also, they're going to subtract to be 4. Because it's negative, the bigger number has to be negative. The larger number is positive. So if I were to solve this equation, this will give me x equals 6 and x equals negative 2. So if I think about what this is on my graph, these are the x-intercepts because it says y equals 0. So at x equals 6, we have a point, and at negative 2, we have a point. We also know that the y-intercept is negative 12 because if x is 0, y is going to be negative 12. Okay, so here is my y-intercept. If I find my vertex, and just because I'm sketching a graph here, my vertex is going to be for the x-coordinate minus b over 2a, which would be the opposite of negative 4 is 4. Over 2 times 1 is 2, so this is 2. So over 2, and the y-coordinate would be, plug the 2 back in, I have 2 squared minus 4 times 2 minus 12, so this is 4 minus 8 is negative 4, minus 12 is negative 16. So my vertex is at 2, negative 16. 12, 13, 14, 15, 16, and over 2. So if I do a quick graph of what this looks like, whoops, let's pretend that is intersecting, and down here, this is what my quadratic equation looks like. Quick sketch. All right, so we want to know where these values are greater than 0. Where is my graph greater than 0? So we're going to do something that's called a sign chart, and this is going to help us determine where our graph is greater than 0. So if I were to make a number line and I put my intercepts on the number line, I have 1 at negative 2, I have 1 at 6. What I want to do is find out where these values are greater than 0. So if I take my factors, x minus 6 and x plus 2, and I want to find out where they're greater than 0 or positive. So we're going to pick numbers that are in each section. So if I pick a number that is to the left of negative 2, like negative 3, and I plug in negative 3 here, I'm going to have negative 3 minus 6 is a negative number, and negative 3 plus 2 is a negative number. So a negative number times another negative number, doesn't matter what the numbers are, is positive. So to the left of negative 2, we're going to have values that are positive or greater than 0. Let's try another one. If I pick a number between negative 2 and 6, okay, so that would be this section of the graph. So let's try 0. If I plug in 0 for x, 0 minus 6 is negative 6, 0 plus 2 is a positive 2. A positive times a negative is a negative. So the numbers in between negative 2 and 6 are negative, not positive. Numbers greater than 6, maybe we pick 8. If I plug in 8, 8 minus 6 is 2, and that's positive. 8 plus 2 is 10, that's positive. A positive times a positive is a positive. So it's in these sections right here that give us our inequality greater than 0. This is where it's positive. So if I were to write this as a solution set using the intervals, I would go from negative infinity to negative 2. And here I would go from 6 to infinity. And it's the union of those sets. So I have this set that gives us values greater than 0, positive values, and I have this set greater than 0. So the two of them together is our solution set. Now, if I were to change my inequality, let's say I wanted it less than 0, it would be the numbers in this section that would give me values less than 0. Let's say if I said I wanted greater than or equal to, and I put an equal sign under here, that would change whether I had a parentheses, I would change that to a bracket around my numbers. Okay, so just kind of giving you a heads up that it could say greater than or equal to, and that would change my notation here with the bracket and the parentheses. So let's do another one. It says to solve the inequality 2x squared is greater or less than x plus 10. So if I were to put this into standard form, 2x squared minus x minus 10 is less than 0. So I want to find out where on the graph is this quadratic function less than 0. So again, if we try to factor, I could break this down, and just doing a little bit of trial and error, I know that 2x times x is 2x squared. And if I have 5 times 2 equals 10, and again, I'm just trying this out, if I were to say 2x, let's try plus 2 and minus here, 5 here. 2x times 2 is 4x, minus 5x would be negative 1x. All right, so that kind of checks out. But again, I want to know, where is this less than 0? And it says to graph the solution set. So I'm going to make a number line. Oops, I actually need to solve these first. So I have 2x minus 5 equals 0. Subtract 5, divide by 2. X is 5 halves, or 2.5. And this one, x plus 2 equals 0. So x is negative 2. So here's negative 2. Here is 5 halves. And I want to know, where is the graph less than 0? So where is it negative? So I'm going to pick numbers, and again, I'm going to plug in and just check the signs. So when I plug in a number less than negative 2, let's put in negative 4. So if I try negative 4, 2 times negative 4 is negative 8 minus 5. This would be a negative. Negative 4 plus 2, this is a negative. A negative times a negative is a positive. A number between negative 2 and 5 halves, let's try 0. I plug in 0 here. 0 minus 5 is negative 5, so that's a negative. 0 plus 2 is a positive. a negative times a positive is a negative. And a number bigger than 5/2, that's 2.5, so let's try 4. So I have 2 times 4 is 8, minus 5 is 3, so that's positive. And 4 plus 2 is 6, that's positive, so this is positive. So I'm looking for where is the values going to be less than 0. So that would be negative. So I'm looking at the middle here. And because it is less than and it doesn't have an equal to underneath, I'm going to use parentheses. It doesn't equal -2, but I'm going to start with -2, and it's going to go to 5/2. Those are the values that are negative less than 0. Okay, so this would be our interval notation based on this sign chart.